Movement forward. The first content unit is moving forward. In this unit, students learn to program the robot's motors to move forward and backward, as well as control the arm and gripper motors in the same way. All content units in the curriculum follow the same format. The first page introduces a real-world robotics scenario, upon which the chapter's final challenge is based. Students should watch the video and answer the questions on the page. The second page contains robot configuration information, which is largely informational, in the sensors sections. These can provide a helpful reminder of where the sensors will be located in that lesson. The next several pages will contain video steps to write a program that performs an important behavior. In this case, moving the robot forward. Students should follow along in their own programming software as the video plays, pausing the video as necessary. After the video steps, students answer some basic check your understanding questions to make sure they understood the video concepts. On some pages, there are additional steps and mini-challenges with their own lesson launchers. Students should complete all of these mini-challenges and other activities up to the optional activities cutoff line if there is one. Activities below the line are helpful and informative, especially for students who are moving quickly through the curriculum, but not critical to the challenge, and may therefore be skipped by students who need to save time. The last two pages are typically a review page with sample solutions to the mini-challenges and the challenge itself. Students can view details and explanations of different parts of the sample solutions by holding the mouse cursor over different parts of the code on screen. The final challenge page presents the challenge and rules in a short video. Then, let students begin solving the challenge. Students should complete the challenge, then move on to the next chapter. In this moving forward chapter, students learn to move the robot forward and backward for different distances, and control its arm and gripper using sequenced motor commands. Movement turning. In the turning chapter, students learn to turn the robot to the left and right in different ways, and for different amounts. Sensors. Distance sensor. Forward until near. The next unit is organized around sensors. From a programming perspective, it specifically centers around behaviors that wait for certain sensor-detectable events to occur in the world. In the Forward until near chapter of the Sensors unit, the robot uses a distance sensor to detect when it is close enough or far enough from a solid object to proceed to another behavior. Sensors. Gyro sensor. Turn for angle. In the Turn for Angle chapter, the robot uses a gyro sensor to detect when the robot's body has rotated far enough to move on to the next programmed behavior. Note that a common confusion that this section attempts to dispel is between the amount a robot's wheels rotate as they move and the amount the robot's actual body turns. Wheel slippage on the ground and varying sizes of wheels mean that these two things are not always the same, or related in the same way. Motor commands control wheel rotation, while the gyro sensor detects robot body rotation. Sensors. Color sensor. Forward until color. In the Forward until color chapter, the robot uses a color sensor to detect when an object of a certain color is in front of the sensor, then move on to the next behavior. The red light, green light challenges in this section place an emphasis on using multiple sensor commands in a row. Stop on red, then wait for green, then start moving again, for instance. Program flow. Loops. The third unit is organized around program flow. Program flow is an organizing principle for understanding which instructions a program will execute and when. You may notice that the videos in this unit talk about flow in a slightly unusual way, which is more literal and machine-like than many curricula. For instance, rather than saying that loops repeat commands, the video characterizes their behaviors as sending program flow back to an earlier point in the program. This is done in order to emphasize the nature of computational control, the highly literal way in which machines interpret instructions, as well as provide students with a useful mental model for understanding conditional and looping statements. In the Loops chapter, the program uses infinite, counting, and sensor-controlled repeat and repeat until loops to repeat sequences of movement commands. Program flow, if-else conditionals. In the if-else conditionals chapter, the program uses if-else statements to execute different sets of instructions based on one-time decisions. Later parts of this chapter combine if-else statements with loops to produce behaviors that repeat the decision-making process, allowing a single piece of code to handle many actions in an assembly line-like setting. Program flow, repeated decisions. In the repeated decisions chapter, the program uses both loops and if-else conditional statements to make and follow through on a decision repeatedly, so quickly that it appears to be making these decisions continually. That is, the robot simulates continuous decision-making by simply repeating the same decision many times very quickly.